Today in this lesson we are going to find the sum of the interior angle measures of polygons. So we've already looked at triangles, now we're going to look at other size polygons. We're going to understand that the sum of the exterior angles of a polygon is 360 degrees, and then we'll also find the measures of interior and exterior angles of polygons. I know I've said the word polygon in class multiple times, but let's just define what a polygon is. So a polygon is a closed plane figure made up of 3 or more line segments. Here are a couple examples of polygons. You want to write these down or make these examples in your notes. And also 3 non-examples of polygons. So notice the curved edges on the non-polygons, and also the fact that this intersects or crosses each other for that one. So that would not be a polygon because it has that intersection point there. All of these polygons again have 3 or more sides. So here's our triangle, and then these other ones we'll talk about some different names for them as well. In a regular polygon, all of the sides and all of the interior angles are congruent. An example of a regular polygon would be a square. So again, all of the sides are congruent to each other, and all of the angles are congruent to each other. Now, when we are looking at types of angles in polygons, there are a couple different types. Either we have convex angles in a polygon or a concave angle in a polygon. And one helpful hint for you guys to, understand these two words, cave would be inside of a hill or a mountain. So those angles, that angle would be going into the polygon. If I were to connect 2 of the vertices, so 2 of the corners together, and that third vertice is going to go into the triangle, and that dotted line would be on the outside. Whereas a convex, all of the angles are pointing out of the polygon. None of them are pointing into the polygon. Again, if I were to connect and basically make a triangle, all of the angles, that angle would be pointing out away from the polygon and not in the polygon like the concave one. Make sure that you draw those 2 pictures into your notes. When we are discussing polygons, we're going to have different names for polygons. Hopefully with a triangle, we know what a triangle looks like, but it has 3 sides, and if it has 3 sides, it also has 3 angles. So just so that you know both of that 3 angles and 3 sides. I'm going to draw a couple of these, not all of them. So an example of a triangle would be that has 3 sides and 3 angles. Quadrilateral has 4 sides and 4 angles. Quadrilateral, some names that you might be more familiar with would be a square, a rectangle, a parallelogram. Those are all different types of quadrilaterals or 4-sided figures. A pentagon has 5 sides and 5 angles. This will be the last one that I will draw. And so there's an example of a pentagon. A hexagon has 6 sides and 6 angles. Hopefully we're noticing that the sides and the angles are the same. A heptagon has 7 sides, 7 angles. You might also see a septagon for a name for that as well. That's often used. An octagon, hopefully we recognize octa on there for octopus, and so it's 8 sides, 8 angles. Nonagon has 9 sides, 9 angles, and a decagon has 10 sides and 10 angles. Anything larger than that, you're going to see like an 11gon or a 12gon. There are definitely names for other ones, but for us, all that we want to work on or make sure that we recognize are these ones, triangle through a decagon. We're going to look at the interior angles and exterior angles of a polygon, and we're going to look at the sum of those interior and exterior angles. We should remember that all triangles have an interior angle sum of 180 degrees. we're going to be doing an activity in class, or maybe we already did the activity in class, where we are going to be breaking down the polygons into triangles. And that'll help relate this, this sum theorem in order to get a better visual for you to understand where these numbers, this formula is coming from. But for right now, how about let's fill in our notes. In the parentheses, here would be n minus 2. And let's also add in that n is the number of sides. Also the number of angles, but we'll just be discussing the number of sides. And so the number of sides minus 2, and then we're going to times that by 180. Make sure that you write all of that into your notes. And then let's look at an example. It says find the sum of the interior angle measures of a regular polygon. So I know a regular polygon has all of the same angle measures and all of the same or congruent sides. If we look at this picture that we have here, we have a 6-sided figure or a hexagon, so that we have our sum equals 6 minus 2 times 180. So again, our sum is going to be 4 times 180. So our sum is 720 degrees. Now in this one, it's just asking for the sum, so we found our answer here. Find the sum of the interior angles of a regular octagon. Why don't you pause the video, see if you can work through number 2 on your own. So in number 2, an octagon has 8 sides. We will go 8 minus 2 times 180. So 6 times 180 gives us an answer of 1,080 degrees for the sum of all of those 8 angles. In example number 3, we want to find the value of x. So the number of sides that we have here, we have, what's here, 1, 2, 3, 4, 5, 6, 7 sides. I just made a little mark so then I could keep track of where I was counting on them. I need to find the total sum first, and then I can set up an equation in order to figure out what that missing x value is of the angle measures. Our sum is 7 minus 2 times 180. So I go 5 times 180. 0, 4,900 this time. So I'm going to set up an equation. I'll go 900 equals the sum of all the interiors. So I have an angle of 125, and maybe I'll cross it off so that I know that I'm done with that one, or make a mark next to it so that I know that I started there. And then 121 plus 160 plus 112 plus x plus 130 plus 128. And then I'll combine all of my like terms, so I have a lot of constants on the right-hand side, so I'll add them all up. And punching it into my calculator, I get 776 plus x. And then I want to solve for x. I'll subtract 776. And I get x equals 124 degrees there. In the last examples that we did, the sum of the interior angle measures of a polygon will change depending on the size of the polygon. But for exterior angle measures of a polygon, the sum will always be 360 degrees. But do notice it does say convex polygon, so it's always going to have those exterior pushing angles, no angles that are going to be going inward for to be able to get that angle measure, exterior angle measure of 360 degrees. In example number 1, I will just add up all of my exterior angles, so 121 plus 62 plus 91 plus x, and that will always equal 360 degrees. So be really careful with this and not getting confused with interior to exterior. I'm going to add up all of my like terms here, and I get 274 plus x equals 360. I'll minus 274 from each side. And I get x equals 86 degrees. Let's look at example number 2. It's very similar. See if you can write the first initial equation, so maybe pause the video, see if you can write the first equation, and then we will solve from there. So hopefully you had an exterior angle of x plus 10 plus 90 plus x, and that will always equal 360 degrees. Combining my like terms, I get 2x plus 100 equals 360, and move over my 100. Divide by 2, and I get x equals 130 degrees. Now in the last one, x here was just what we were finding. Now in this one we want to go back in and plug in both of those angles. So the x value, this one is going to be 130 degrees. And then this one over here, we're going to have 130 plus 10 to give us 140 degrees. Now don't forget to do your summary. Remember, you are talking about what you learned in the video. Some things you might want to write about is how can you find the interior angle measures of a polygon? How can you find the exterior angle measures of a polygon? Maybe talk about the different names of polygons. And then for your question, find the measures of the exterior angles of this polygon down at the bottom.